på knap nu. Jeg venter lige på et go fra min kollega, som siger, at vi er live. Er I klar? Jeg venter på et go. So, welcome and researchers ahoy today. Today we are going to have a really thrilling Titbit experience, as it's going to be as physical as it can be, because we are going to put some alternative fuels, some future fuels and green fuels into the engines of the ships. Well, we're not going to do it right here, but we are going to see some of the videos and experiments that Anders Ivarsson from DTU has been carrying out together with his fellow students and colleagues at DTU. So, welcome to the latest and hottest research results presented by Marlock Titbits and Maritime Research Alliance. This Titbit has come to the program in a very, very nice collaboration with Thomas Rosling, who is together with us, assuring that you out there can digest this valuable information which is produced at the universities. So, what are you going to expect here for the next 30 minutes of Titbits? Well, a few of you have not been attending Titbits before. So Titbit is a little bit of a cozy webinar where we are having one part of TED Talks and one part of talk show. That is why we are not having boring logo backgrounds or blurred backgrounds. As you see, I'm here in my home, surrounded by some of my plants, and Anders, he is in his office at the DTU, and his plants has become paper. So, no, we will have, after my short presentation here, we will have a 15 to 20 minutes presentation by Anders, and then you are so welcome to ask all your questions in the chat, and we will answer, Anders, he will answer the questions afterwards. Anders will answer, that's a difficult one. So, oh, somebody is coming home here in my home. This is what's going to happen when you're working from home. This is a little appetizer of the knowledge, and you're of course welcome to reach out to Maritime Research Alliance afterwards if you have other questions to this. Good, let's get started. I'm Henriette Dybkjær. I'm working for Marlock, and Marlock is the brand new supercluster of maritime and logistics here in Denmark. We was settled down on the 1st of January, and we're a fusion between MDC in Copenhagen, Marcot in Frederikshavn, and Fyns Maritime Klynge at Fyn. So let's get started. Let's have a cheers for a wonderful Titbit, and welcome to Anders Ivarsson here in the Titbit studio.
Yes, thanks a lot. And I will be sharing and hope you can see this.
Anders, is just fine. Go on.
Yeah, can you see my presentation?
It's just perfect. I can see your presentation and see a small video with you up in the corner.
Okay, great. So yeah, I'm supposed to give a little pre-taste on these green marine fuels that we're looking at in our combustion engine lab. So there's a lot of fluffy talk about Power-to-X and e-fuels and so forth, but very few actually know how the flavor of these fuels are from the engine perspective, and I will try to give a little pre-taste on that. So the first fuel that I will give a taste on is lignin fuel. The concept behind the lignin fuel is to extract lignin from the waste coming from, for example, in this case, a biorefinery producing bioethanol. This can be extracted in various processes here using either ethanol or methanol as solvent, and then the lignin can be further concentrated into a bio oil. The thing is that this fuel have potential of being much cheaper than bioethanol or methanol, but it's also a rather difficult fuel to burn. And if it's supposed to be burned in an engine, then the engine best suited for that would definitely be a marine engine, because it's optimized for burning heavy fuel oil or bunker fuel. And comparing lignin fuel with heavy fuel oil, then from its first appearance, it looks pretty much like each other. It's thick and it's pitch black and it's sticky. And the viscosity of it, so the thickness of it is rather high, the viscosity is high. And for marine engines, it's required to heat heavy fuel oil in order to reduce viscosity and achieve a good atomization when it's injected to the engine. This is also required to some extent for the lignin fuel, dependent on the lignin concentration. It's not as viscous as the bunker fuel, but still it may need some heating. And that is when the comparison stops, because the lignin fuel also contains solvents, which is ethanol or methanol, which are ATEX fuels. So it will require, if heating is required with heat tracers, then you have to combine ATEX approved fuel system and also have heating heat tracers installed. And that is something that we would like to avoid. So we're trying to challenge the injection of lignin fuel without and reducing the requirement for heating as much as possible. We are also looking at requirements of a pilot flame in order to ignite it. This is what we are testing in this project that we got. We are testing very small samples. And that's because those different formulations of the lignin fuel is produced in very small scale at the University of Copenhagen. And then they provide us with some samples that we are testing in our equipment. So here it's to the left, it's an IQT, an ignition quality tester. And to the right, it's a modified HUTS engine. And I'll try to explain a little bit more about the IQT. So it's basically a combustion chamber at 45 bar, so rather high pressure and high temperature. We have altered both pressure and temperature in order to achieve ignition of poorly igniting fuels like marine fuels. Then we also modified the entire injection system because it's required to heat the fuel to some extent, and also pressurize it in order to avoid evaporation of the solvents. Then it should also be able to circulate because of the heating. And so it's our own design of an injection system. And using this, we can measure the delay from injection of the fuel to the first sign on of ignition. And we had very promising results with the lignin fuel, showing that the lignin content actually increases the ignitability quite significantly. So that is a very promising result from these first attempts on testing this lignin fuel. However, when we went to higher concentrations, then it becomes a little harder because the ethanol evaporates from the backside of the injection pump, and a sticky substance of the lignin is left, and the plunger tends to get stuck. And also what can be seen from the measurements is that the ignition becomes rather inconsistent. So these are improvements that we need to make on the IQT that we are currently trying out. We created a oil chamber where we can pressurize sealing oil in order to avoid any leaks of lignin through the clearance of the plunger pump. This is basically the same concept as marine engines use from MAN using methanol engines, using methanol engines and propane engines. So it's not a new thing, but we have to improve our setup in that direction as well. Yes. Then we also do engine tests. We have this modified Hartz engine where we can drive the engine with an electrical motor, which is located below the engine. The motor is driving the engine without any fuel consumption of the engine. So, and then we can pressurize and heat up the intake air. That way we can run the engine and heat it up, and then we can try to inject a small amount of fuel and see if it burns and produces power. And this is a quite important feature of this setup, because what happens if we have too many misfires of lignin is that the lignin part of the fuel builds up in the engine, and the result would be stuck piston rings and extensive blow-by in the engine. So this also suggests that the marine engine using a pilot flame to ensure ignition may be the right design for that fuel. So that was one very interesting fuel, but also a very difficult fuel, as you may have noticed from my presentation. But to another also challenging and very interesting fuel, which is ammonia. So ammonia is very different from any other fuels that we know, because it's hard to ignite, and it is burning very slowly because it has no carbon in it. So it is different from any other hydrocarbon fuels that we have experienced with. We have, however, had research on this for more than 10 years, where we did some initial research using hydrogen as ignition promoter. So a small amount of hydrogen was mixed into the ammonia and tested in this cooperative fuel research engine, which was modified quite a lot. This is a premixed engine, so it is comparable with low pressure gas engines, where the charge is premixed prior to ignition. And using a slight amount of hydrogen added into the ammonia, we could get very promising results in terms of efficiency. Here it's above 40% indicated efficiency, which is really good for that engine. An interesting thing was also to study emissions. So we were quite sure that there would be a lot of NOx emission would be quite significantly, but the question was if we could keep ammonia slip low enough. And that has been the case in these experiments, that the ammonia slip was lower than the NOx emission, which is then actually not a disadvantage, because the ammonia will then be used in the SCR catalyst to remove the NOx anyway. Actually, we will have to add a little bit ammonia in order to remove all the NOx. Another thing of concern was nitrous oxide. if we could keep that low enough, because that can be a total showstopper of using ammonia in engines. Nitrous oxide is a strong greenhouse gas, and if the slip is just a few hundred ppm, then the whole idea about using green ammonia is gone. But these experiments show that we could keep it rather low in an acceptable range. Now, the problem with these experiments is the presence of hydrogen, and it's not desired to have hydrogen on board a ship, particularly in combination with ammonia, which is toxic, and the hydrogen is highly explosive. So what we are currently doing in our investigations is to use we are installing a high energy spark system where we can adjust the parameters accurately and challenge the limit of ignitability of the ammonia in a premixed condition by also pressure charging the intake more than we did before. And this will probably be a promising engine concept for marine application, particularly for ships where boil off gas from ammonia tanks should be used in the engine right away. However, when it comes to high reliability of the engine, then there's nothing that beats the non-premixed compression ignition engine. And this is also something that we will test on this HOTS engine. It's modified with a pressurized small, with using a small sample of fuel, a small tank there, and we can pressurize and heat a little bit also this fuel system and measure the fuel consumption using the scale. And with the preheat and pre-pressure of the air intake, then we can try to burn ammonia in that engine in a non-premixed spray combustion state. However, we are quite sure that we will never get any ignition on pure ammonia in that setup because there's no pilot flame. We will, however, try it with mixing a little bit of DME into the fuel. And the question is that then how much DME will have to be mixed into the ammonia in order to ensure good combustion. What is also interesting to analyze from these experiments are the emissions, how it will influence the emissions that hydrocarbons are mixed into the fuel and burned in that manner. But for the pure ammonia spray combustion studies, we will challenge the limits in our optical combustion vessel, where higher temperature than achievable in the engine can be simulated, and then we can challenge the limit of the ignitability and spray formation and flame formation to see if altering the spray, the injector, can improve on that. So we are currently adding ammonia injection system, building and adding an ammonia injection system to our optical combustion vessel. And we intend to do that with both a diesel injector and the ammonia injector in order to study pilot flame ignition of the ammonia spray as well. So that was two very interesting and but also very difficult fuels. And I think they will be very specialized fuels to use. And I'm sure there will be parts of the fleet that will be using those in the future. However, for the majority of the fleet, they will be probably be too difficult and expensive to use. And that's why I also would like to advocate a little bit for my absolute favorite fuel, which is dimethyl ether. It's not known by so many, and it's not traded that much, but you may know it from your hairspray if you have any hair. I'm not using it that much, but it is used as a propellant for hairsprays, and it's good for that because it's non-toxic and it has a low global warming potential. Now, dimethyl ether also have the property of carrying an oxygen atom between the carbon atoms, which gives it some special combustion properties. It also is stored at rather low pressure, and it does not require a lot of cooling in order to be stored as liquid. But maybe most importantly, apart from also the combustion properties, is the lower heating value, which is high. And I'll try to illustrate that a little bit more. But first, the combustion properties, because all other green alternatives have a very low ignitability. They are difficult to ignite, and it requires a pilot flame in order to ignite them. And the yellow flame you see here is the pilot flame, and then there's, in this case, the methanol coming in below it. Well, DME would not form a yellow flame like that because it's a non-suiting fuel, and but it would ignite right away soon after injection, similar to marine oil or diesel fuel, which was the top one. That is a great feature of a fuel for diesel engines, and it's not new because experiments around the world, fleet demonstrations have shown that it's a promising fuel for diesel engines. In China, they had fleets of buses and garbage trucks driving on DME since 2005. And they actually have the largest DME production capacity in the world. In 2015, it was corresponding to, they had the capacity to produce enough DME to fuel the entire Maersk fleet. And actually the production rate was much lower because they never, the demand of DME in China never came to the level as expected, because the reason they produced the DME was to to reduce the dependency on LPG import. However, availability of LPG continued and prices were low, so it was a little hard to compete with. And DME is now used as 20% addition in the cooking oil and DME, and that's why the production level is quite low. Of course, all this DME was produced from coal because it was only to become independent on LPG import. But the thermal gasification process used for producing syngas from coal and further synthesis into DME or methanol, which is actually produced on the same plants, it's basically the same as if biomass is used. And this process could be significantly boosted by adding hydrogen to the synthesis, green hydrogen, of course, and oxygen to blow the gasification process to some extent. So this is what we are looking at, particularly for China. And when we look at a map from China, then we will of course see that the DME plants, they are placed located rather close to coal mining. And this will, of course, be different if biomass was supposed to be used, because the marginal land, which is not good enough for agriculture, but could be used for careful growing of energy crops, is a much larger part of China. So it would be maybe this area here. And then wind energy is Inner Mongolia, where they have quite a lot of energy parks, which are not super efficient because they can't they are not connected good enough to the grid to get to sell the electricity. So this is what we are considering, how this could be made in China. And what this map also shows is that the fuel of the future will be produced very distributed, not only in China, but the entire world, where we have sustainable energy, either as biomass or wind energy, and then it will have to be moved around. So that is changing the picture from large fuel suppliers using bunkering systems, I think, and that is what we are considering if we in this future have a more mobile system using tank containers. Then it would change the situation that fuel traders could buy some tank containers containing this new fuel and to deliver it in the harbor. And when ships are, for example, unloading containers, then they could load the amount of fuel they need for the next part of the trip. They could be connected with switch connector, quick connectors, like the one showed there. Yeah. So that was a little bit about logistics and bunkering, and considering this also should be taken into account how it will influence the cargo space capacity and payload capacity. And then if we do this using either ISO 50 tanks, which are approved for LPG and DME and ammonia, and T11 tanks for methanol, then we can get an idea about the reduction, how much cargo space needs to be sacrificed. And then the advantage of DME's high energy density also shows, because the sacrifice will be less when using DME. It will be less than 2% reduction compared to maybe 3% in cargo space of ammonia if it's stored in that way. And that's only on the ship. Then you should also consider the entire infrastructure of trucking fuels around on the roads and everywhere. So I think energy density is a very important factor to consider here. Now, as a final thing, I would mention that we participated quite a lot in this chalet marathon at DTU, and in the early days we were also allowed to use more advanced fuels, and we used DME, and I think that was the nicest engine that we ever built, because it was a modified two-stroke engine using a direct injection of DME with compression ignition. And I thought that I would share with you the nice accelerator response of that engine, because it's a fantastic fuel and you immediately fall in love with it when you use it in engines. And I'll try to share that feeling a little bit with you. So coming here. Yeah, it sounds like a race engine, but actually it was a competition about reaching the longest range on a liter of gasoline equivalent, and that particular engine did 598 kilometers on a liter of gasoline equivalent. So that's it.
That sounds just great, Anders. I'm just getting back to you here. Yeah. Hi again, Anders. We're back. I didn't know that you could fall in love with a fuel or an engine. Then you are passionate about your job. It was really interesting for me, who doesn't know anything about engines or marine fuels at that level that you do. I kind of not understood 100%, but I think you gave a very good overview of also the pros and cons of the different fuels. That was actually what I wanted to ask you, but here in the last slide you gave this very great overview about the different characteristics of the fuels. So my other question that I had prepared for you was, what is your favorite fuel? But that was also obvious, and there has come some other questions to the chat, so let's dive into those, as I have no more questions to you. You answered all of them, Anders. We have Lene Mahler, who is asking, what is the current price of DME compared to other marine fuels?
Yeah, the DME, the current DME price, spot market price, is on energy basis the exact same as methanol, because it's produced on the same plants. However, it's not green, because it is the current methanol production is not green, and also not DME, and ammonia is also pitch black today. But if you're looking into what the price would be if it was produced green, then it would also be the same as methanol, but more expensive than the current price tag, of course. So.
Great. Brings me to the next question from Knud Tybjerg. I know he's from Samsø, where they are actually doing some experiments with the biogas and biomethanol. So he's asking you, what about like liquid biogas and biomethanol? How is that in your view and in the green fuel?
Well, biogas, I'm not a big fan of biogas for engines because it's really hard to avoid a slip of methane. I think there are much better applications for biogas. If you look at the entire society, for example, energy intensive productions of, for example, cement production and other energy intensive production facilities. That's my opinion about that. And methanol is a great fuel. However, I prefer to use it in light duty engines, because gasoline car basically can basically be converted very quick and easy into a methanol car, and methanol is a better fuel for those types of engines, the cheap light duty engines, and you can actually improve the efficiency of those engines using methanol. It's also possible to use it, of course, in marine engines with a pilot flame, but the disadvantage of using pilot fuel is you will always need two fuel systems, because you would like to have a backup system anyway. But the requirement of having a pilot flame to ignite the fuel also means that you have a consumption of pilot fuel, and this consumption increases if traveling at if you're slow steaming with ship. Then it actually becomes significant the consumption of pilot fuel. Yeah, so that's why DME is better, and it's produced on the same plant as methanol at the same price tag. So why not use the best fuel?
There are a lot of things to consider also when you are switching from one fuel to another in the engine, and when you are when you're tanking your ship, how many tanks do you need to have with one fuel or another? There are so many things to consider. So yes, I fully agree with your consideration there. Well, we have nearly come to an end, and Thomas Olsen, he is asking, well, you probably a little bit answered this question, but he says, can use of these three fuels in existing ship engines, can you use these three fuels in existing ship engines, or do you need to modify the existing engines, or do you need completely new engines? You've answered. I want to give
so the lignin fuel, we try to, develop formulations of lignin fuel that can be used with minor modifications of methanol engines, marine engines. Ammonia is quite a different story. There is required some more research on this in order to develop engines suited for ammonia, but I'm sure they will come, and we are still on the concept level of choosing the best suited concept for those. So to that, the answer is no at the current level, but in few years, then it will be there. I'm convinced about that. DME is basically a LPG engine, and I'm quite sure if you ask MAN Energy Solution if you can buy a DME engine, then it's more or less to put it in the basket, because it's basically a LPG engine where you switch off the pilot flame and only run DME. It's requiring maybe some other gaskets, but it's not a big issue basically. So it should be rather simple to use a LPG engine for DME, and you can even buy retrofit for ships for LPG retrofits. So yeah, it's not that difficult, I think.
So do you think that this, we are a little bit over time, but I would like to know if you think that we are going to see a multiple fuel landscape or a more single fuel landscape as we have today with the heavy fuel?
No,
so
we'll see many heavy fuel? We will see many different fuels, because what is driving the development mainly right now is the chemical carriers, and it's obvious an advantage for them to use the fuel already in the cargo. And in the future, we will see more methanol carriers. They will use methanol engines. We will see more ammonia carriers, because ammonia is a fantastic energy carrier in itself. And that would be an obvious choice to use ammonia engines for those carriers, for these carrier ships. And then I think the lignin fuel will probably also be a little bit specialized, because it requires a good organization to purchase and to check if it's the right fuel you got, and to use it on the ship, education of the staff and so on. But it will probably be cheaper, or has the potential of becoming cheaper than other green fuels. Maybe, I'm not sure. We'll see. But that is what we expect. And but then, yeah, my point is, and then DME, of course, if production of green DME is coming, then I think that will be a very suited fuel for many parts of the merchant fleet. That's my gut feeling, at least. So we will see a large variety of fuels.
Yeah, that is also what we think will be coming. And my last comment will be, so if I was a ship owner and I wanted to buy a ship, I would probably go for a chemical tank ship, not for a tanker, for a container ship, but because there should be an increasing market for transporting this stuff around in the future. What do you think?
Yeah, maybe. Yeah, I think some of it, but then there will be less of other fuels moved around, right? And so the fossil fuels, I would love to see it happen before I conclude anything, but I guess it should hopefully drop the use of fossil fuels. Then there will be other fuels, yeah. But in an ideal world, it should also be produced more locally. So, but the thing is, we have wind somewhere, biomass somewhere else, and maybe we have some specialized production plants in the third place, and the customers are fourth place, and so on. So it will be a totally different logistics to deal with, I guess. Yeah, I'm not sure if I answered your question.
Well, I will take this question with me, because in a couple of weeks we have Peter Sand, who is chief analyst of BIMCO in the Titbits studio, and I know that he has been listening along today. So I will ask him to do his homework and tell us a little bit about how he will see the situation of the future complete market on what kinds of ships will be rock and roll in the future, considering the new fuels. We have so many tank ships. So this is just a funny thought. Good. Anders, it was really, really interesting. And I can also see that we had a lot of participants joining us today. So I hope that all of you had a great lunch break. And I also hope that you got the opportunity to grab some lunch before next meetings coming up in your day. Thank you so much for listening along. Thank you to you, Anders, for sharing your huge knowledge and great films, and also the little, I will never forget about the hairspray. Everything I will use my hairspray, I will think of DME. So I think this is the future fuel for the ships that I'm putting in my hair now. Oh my God. It was really, really fun. It's we are going to close down Titbits for the next week, where we are celebrating the Easter break. And that means that our upcoming Titbits will be the week after Easter. And there you're gonna dive into topics as how to control your suppliers in accordance to the cybersecurity. That's gonna be the first one. And we are also gonna have a tidbit about the future of blue economics. That will be Matt Spaniel from Aarhus University, who is looking into the future and seeing when can we expect drones, when can we expect a lot of the new technologies coming into our maritime and logistic business. So very, very interesting stuff coming up. My colleague, she has put in the chat where you can stay tuned on it. And then there is just to say, we are not sure that we can share this awesome video at our YouTube Titbit channel, but we will let you know if it comes up, because this is kind of stuff which is not to be divulged everywhere. So we will be back and tell you if it will be available. Else, lucky you that got this tidbit. Have a wonderful day, have a wonderful Easter, and thank you everyone. Bye bye.